street teacher, your science teacher online. Alright, today we are going to do justice to this topic, the modern theory of the atom. The modern theory of the atom. Surprisingly, one will be wondering why we're talking about the modern theory of an atom. Yes, it's important we talk about the modern theory of an atom because already we have the earlier theories of the atom. For the benefit of the doubt, we are going to look at the earlier theories of the atom that will bring us to the discussion of the present or the modern theory of the atom. This is Dr. B Science Classes, both on YouTube and on Facebook. So if you go to Facebook, you just type Dr. B Science Classes, on YouTube, Dr. B Science Classes. You are going to see more and more of these videos online. Now do not forget that you owe me a duty to share this video to your various platforms and your students. Do not also forget that when you share, tell them to subscribe. Subscription to my channel is free. Nobody charges you for anything. So tell them to subscribe, hit the subscription bell, and that is all. So you can have more videos once they come up. Now do not also forget that on Facebook, you need to tell them to also do what? Follow. Once they click on the follow button, that is all. Everything is free. Leave your comments, even their questions. We will answer them for you, and also leave your likes as well. Now, thank you very much. Let's come back to business, the modern theory of an atom. Now, one will be wondering what is even important about an atom. We have been hearing of atom here and there. We were told that atom is simply defined as the smallest indivisible particle of an element. That is what we used to know about an atom, and I'm sure that is what you also know about an atom. That an atom is simply the smallest indivisible particle of an element. Now, that is a definition that describes an atom in the earlier theories. Because in the present theory, in the modern theory of an atom, that definition is not all correct anymore. So today we are going to let us know what the new definition of an atom is following the modern theory of an atom, and some basic things that have been corrected in the current or modern theory of an atom that you may not know. Now, do you know that generally an atom is made up of electrons, made up of neutrons, made up of protons, made up of even orbits? Okay, so when you take a look at this diagram here, this diagram explains the atom, a typical atom. Okay, so it explains how a typical atom will look like. An atom has electrons around it, okay, and then it has orbits, okay, which you could call orbitals. It has orbits or subshells, as the case may be, and then it also have a central nucleus. Alright, so the central nucleus of an atom is expected to bear the proton, to bear the neutron. And of course, it is the presence of the proton and the neutron that defines what the nucleus of an atom. Of course, it is the nucleus of an atom that holds the mass of what? The entire mass of the atom. So, when you take a look at this description of an atom, which every element has, you will see that this description is not completely the design of the earlier theories of an atom, but more of the design of the modern theory of an atom. I'm going to explain this as we go. But it is important for us to first try to look at what the earlier theories of an atom try to describe an atom before we try to come looking at the modern theory of an atom. That is the only way we will be able to comprehend what we want to do here today. We cannot talk about the modern theory of an atom without having at least a brief on the earlier theories of an atom. Now join me. Let us look at what the earlier theory of an atom talks about. Now, before we look at those people who looked at the earlier theory of an atom, or who look at the atom those earlier days, we have to look at someone very important, and his name is not among these people, and that is Democritus. Democritus existed around the period of 500 to 400 BC. Democritus is one person who coined that name an atom, meaning that if Democritus was not even in the picture, then the name atom would not have been, perhaps. So Democritus is one person that cannot be forgotten when discussing an atom, even though much of Democritus' work about an atom were more theoretical and not experimental. No wonder somebody like Aristotle had described Democritus as a quack. But never mind about that. Even if he was described as a quack because he did much of his findings about an atom in theoretical perspective, not experimental perspective, his work still counts. His name is still remembered. His work took a very long time before being verified, more than 2,000 years before being verified. And that is because much of what he did about an atom, talking about Democritus, was more theoretical and not experimental. In the field of science, if you want to perfect whatever work you're doing, if you do it and do a theoretical work, there must be an experimental backing that the results match with that of theoretical. But since Democritus didn't do that, his work was termed as quack because there was no experimental backing. But whether his work was having experimental backing or not, the truth remains that Democritus is credited with that name atom. Democritus was only doing a little bit of his work outside. Okay, he didn't mean to develop anything, but in the course of what Democritus was just doing, he picked particles of elements and tried to put the particles of elements together, fused them so strong, and found out that they held together and formed something he could define as atom. And I bet you that name atom was more described to something that was indivisible. So since he picked particles of different elements, okay, the same particles of elements on the ground, and put them together, fused them, and formed something he felt it was indivisible, he claimed it was called an atom. And that was how the name atom came about. The name atom actually denotes something that is indivisible. He believed that an atom is made up of particles of the same element, which I agree with you. Okay? But he said that these particles are indivisible. That's why he called them atom. And went further to say that though these particles are indivisible, but they can differ in terms of sizes, in terms of shapes, and even in terms of orientation. That is much I'm going to tell you about the work of Democritus, but I just want you to know that Democritus is one person we cannot forget when talking about the earlier theories of the atom, because he is the one who is credited with that name, atom. Now let us move forward. Now after Democritus, around 5,000 to 4,000, from 500 to 400 BC, came another physicist who was called John Dalton. John Dalton theory came around 1803. This tells you how scientists were working. So that's why we say that it took up to 2,000 years for that theory of an atom described by Democritus to be verified. So you can imagine that 500 to 400 BC, it was not until 1803, that is about the 17th century, that you now have the Dalton atomic theory. Dalton atomic theory is a very pronounced theory that even till date it is still being discussed. This is because Dalton was one man that was able to bring to the understanding of everything that an atom was. Whatever Democritus was trying to talk about, trying to explain as an atom, it was John Dalton that was able to bring the picture to the face of the scientists and physicists to understand what an atom was. And he's credited with what we call indivisibility unit. John Dalton is believed to know that he is the one who actually defined an atom as being indivisible, even though Democritus also looked at it from that perspective. But the one who actually brought the full idea about the indivisibility of an atom was John Dalton. John Dalton presented about 5 theories, which we call today the John Dalton atomic theory. And these theories he presented had some problems, and they were corrected in the modern theory of an atom. Now I want to let us know that because of John Dalton's theory and his understanding of the atom, he is also credited with what we can easily call the billiard ball theory. The billiard ball atomic theory is credited to John Dalton. This is because if you know what a billiard is, okay, some of you call it, is it snooker or something, or snooker or something. Okay, so that is a billiard. It's a little bit different from a billiard, but a billiard is almost like a snooker. Now the balls you use in playing snooker is what John Dalton tried to visualize as being an atom. He believes that each of those balls contain the same type of elements, just like what Democritus said. And he believed that they are fused together in a stronger way such that it is not breakable. And that is why we called the John Dalton atomic theory as the billiard ball atomic theory. And he's credited with indivisibility. He believes that atoms of elements are indivisible. Okay, that is John Dalton for you. I'm not going to talk much about John Dalton atomic theory and the corrections in his postulations. We are going to do a class on that. I'll show you. Now, after John Dalton came J.J. Thomson. J.J. Thomson is another physicist who attempted to look at the atom away from what John Dalton saw it, and that was around 1904. You can see how long it took for each of them to study the atom that another did. Okay, now J.J. Thomson looked at the atom, and he is credited with the electron. That means that it was J.J. Thomson that was able to do what? To describe the existence of electron in an atom. So J.J. Thomson is credited with what? With electron. That means he was the one who, now one could say, who invented, so to say. Well, okay, let me just say in quote, but he is the one who was able to bring out to the knowledge of people that there was what we can call an electron existing in an atom, and he believes that this electron is always found just around positively charged ions. Okay, that's what he believed. So when you look at the work of J.J. Thomson, you see that J.J. Thomson worked hard on that. Now the problem about J.J. Thomson is that he could not explain what Rutherford explained with respect to electron bouncing. Because there are some electrons that when you bombard them, and atoms that you bombard them, for example, their electrons are going to do what? Are going to bounce back. So that was just a little bit of a challenge that came from J.J. Thomson. But the fact that J.J. Thomson contributed to the atom such a way that you and I today know that an atom has electron, it is something that is worth talking about. So to know that an atom possesses electrons, it was the handwork of J.J. Thomson. Now, after J.J. Thomson came Ernest Rutherford. Ernest Rutherford was another scientist in 1911, some years away from J.J. Thomson's work, who attempted to discuss the atom. But believe you me, that all these scientists were also still believing that an atom was indivisible. They did not deviate completely from what Dalton said, picking the work of Democritus. They did not deviate from that, but they were only establishing some new things that were part of an atom that had not been actually envisaged. Okay, so Ernest Rutherford was the next person online in the earlier theory of the atom who believed that the atom had a nucleus. You can see how it came. So it was not just one person that woke up one morning to tell you that an atom has electrons, atom has orbitals, atom has this, has that. Every of these scientists was able to detect something about an atom. While this one was interested in understanding that an atom is indivisible, has particles that can be fused more like a billiard ball. This one, J.J. Thomson believed in the plum pudding. He believed that there were electrons that were surrounding a center of positively charged, and he called it the plum pudding model of an atom. The plum pudding model of an atom. That model belongs to J.J. Thomson. Now, Rutherford came on board and believes that there was a nucleus in an atom, not just electron as being founded by J.J. Thomson. So in 1911, Ernest Rutherford, was able to bring to the light of science the fact that there was a nucleus in an atom, and that this nucleus has what? Is positively charged. Okay, now because of that, because of Rutherford belief in that way, his theory was narrowed. His type of atomic description was narrowed to a nuclear atom. So you can see that his own understanding of the atom, and again from the fact that he was able to develop to bring to the light of science the presence of a nucleus, his theory is being described as what? As the nuclear theory of an atom. Why this one? Because of the electrons he founded, it was now believed that his theory is narrowed toward the plum pudding. Now this one, because he believed in indivisibility, his theory was also what? Narrowed to what we believe as the billiard ball atomic model. Now you must understand all this. Now the work of Rutherford took us to the work of Niels Bohr. Niels Bohr is another very powerful physicist in 1913 who also attempted to look at the atom from the way these other people look at it. And the Niels Bohr model is such that we can describe it as the galaxy. So this Niels Bohr model is described as the galaxy model, the atomic galaxy model, because Niels Bohr tried to look at the atom from the perspective that atom possesses what we call energy levels, subshells. So he believed that yes, it is true that atom is indivisible. It is true that atom possesses electrons. It is true that atom possesses nucleus. But it is also true that atom possesses what? Orbitals, where the electrons are fixed and are moving all around. So in that theory, he looked at an atom from the perspective of what? Of the galaxy, where you have the sun and then you have the planets running round the sun. So he looked at the atom in that way. He believed that atom is like a sun with a nucleus at the center, and then the electrons are like planets with orbits moving around them at fixed position. Now that is why his theory is being described as what? As the atomic galaxy theory. So you can see that all these people, beginning from Democritus, contributed seriously to what we know today as atom. But the man that broke the camel's back in the understanding of the atom in totality, that today we describe as the modern atomic theory, is Ernest Schrödinger. Sorry, Edwin Schrödinger. So Edwin Schrödinger in 1926 was the one who today is credited with so much about the modern theory of an atom. So whenever you talk about the modern theory of an atom, we are giving credit to Edwin Schrödinger. He described the atom from another perspective entirely, which is called quantum mechanics. Every of his discussion under quantum mechanics take us to the correction of one or two things in the earlier theories of the atom. Now, how did Edwin Schrödinger, using quantum mechanics, was able to discuss the atom that today we are describing as the modern theory of an atom? Ernest Schrödinger believed so much in one thing, which is called the wave function. Wave function is a strong mathematical tool that is used in statistical mechanics or in quantum mechanics to solve problems. We are going to mention two or three different ideas of Edwin Schrödinger in his quantum mechanics description of the modern atomic theory, and you are going to see that much of the works that were done by these many in the earlier theories have been corrected. And the number one is the definition of an atom. I told you I'm going to come back to that. Remember that all these people believe that is the earlier theory, believe that an atom cannot be divisible. They believe that, that's why they said atom is the smallest indivisible particle of an element. But today, Edwin Schrödinger is telling you that it is not true. It is not true. He says atoms are what? Are divisible. And he defined it instead of the other way. He said the correct way of defining an atom is the smallest particle of an element that can take part in a chemical reaction. So if you want to define an atom and you said an atom is the smallest indivisible particle of an element, you are defining based on the earlier theories of an atom. In the modern theory of an atom, credited to Edwin Schrödinger, okay? Credited to Edwin Schrödinger, the modern theory of an atom, credited him, it says atom is the smallest particle of an element that can take part in the chemical reaction. From today, that is what I expect you to be defining as an atom. And how did he come about it? He said, look, we can't say that. We can't say that because, one, we have what we call radioactivity. Radioactivity, okay, has to do with the bombardment of an atom of a particular element to get another smaller one. For example, uranium. You can bombard uranium-235 to get what? To get thorium. Now you can see that if an alpha particle is used to bombard uranium atom, it will break down and give you thorium. And it will release what? A helium atom. That is for you to know that. That is why Schrödinger says that definition that atoms are indivisible is not true, because there are atoms that can be bombarded and they will do what? They will divide and give you another new one. Uranium, bombard with helium atom, with alpha particle, is going to do what? Break down into pieces and give you thorium atom and a helium atom. So it means that, from his own explanation from the quantum mechanism, it means that atom is divisible. Now, if that is not good for us, he also said, look, we have what we call isotopes, where we say that we have different elements out of one element with what? With the same atomic number, different mass number. For example, carbon. You have carbon 12, you have carbon 13, you have carbon 14. They are isotopes. You can see that they are from carbon, but they are different masses. They are different type of carbons, which means that you can actually divide carbon into different types, which makes carbon atom divisible. Now, even if that was not true, how about the fact that we accept that an atom can actually has a proton, a neutron, electron? That shows that it is actually divisible. Now, Schrödinger, from quantum mechanics, have seen it from that perspective, and that's why he said an atom is divisible, with many other reasons that time may not permit us. Okay, that is one from the modern theory. The second one is the issue of what? The issue of fixed circular orbits by Niels Bohr. He believed that, from the modern theory, he believes that if we follow Niels Bohr and say that there are orbits that are fixed and electrons are moving around it like this, like the galaxy, it will not be true, because a point will come when this particular electron will lose hold of the grip of energy that is coming from the nucleus and will collapse into the nucleus, and that means even life itself will not exist. So we cannot liken the atom and the electrons to that of the galaxy, that of the sun and the planets. No. So that issue of his planetary atomic theory is not honored by the modern atomic theory. The modern atomic theory believes that there is what we call orbitals, or you can call them the wave function. So they believe that there is an electron cloud around every atom. That is to say, you cannot find an electron at a particular point, at a fixed point. You cannot find electrons like this at fixed points around an orbital. So he believes that you define an orbital just the way you define a wave function. So if electrons are found at different positions under probability, then it means that it is not possible for you to say that the orbital will collapse into the nucleus. That was another serious breakthrough for Schrödinger in the modern theory of an atom. And that is why he chose to define an orbital in a different way from how it was defined from the earlier theory. And he looked at an orbital as any region of space around the nucleus of an atom where you can probably find concentration or clouds of electrons. That's all. That is all. He did not see an orbital like where we are told in the earlier theory that it is a point in the orbit where you can find an electron. No. He said, in that way, you are defining it that electrons are fixed at a point. No. He said, electrons can only be found under probability. That means that you can find electron at this point, you can find electron at this point, you can find electron even at this point. You cannot find it only at a particular place. Electron can be found here, can be found here, can be found here. That is what modern theory says. So he simply said that the probability of finding electron, cloud of electron, at any region of space around the atom is defined as a wave function or an orbital. That corrected what Niels Bohr said in his planetary discussion of an atom in 1913. And so many other things that the modern theory of an atom tried to look into and discuss. And the modern theory of an atom also believes that there is a nucleus that houses the mass of the atom, and that nucleus possesses a proton and a neutron, and that the sum of the proton and the neutron is what defines the nucleus of an atom. That was not clearly discussed by the earlier theory of an atom. You can see that the modern theory of an atom has done so much work to correcting a lot in the earlier theories of the atom and put science at a very good perspective that you and I today are enjoying the works of science. We can go on and talk about the modern theory of an atom, but let me not bore you with so much. I guess that we have done much justice to this topic today. Like I show you, the next time we are going to meet, we'll talk about the Dalton atomic theory. Thank you for being part of this class. It's quite impressive having you being part of this class. You can read more materials to understand this for yourself. Dr. B Science Classes, Facebook and YouTube is the name. Share, like, subscribe, and leave comments. Until